Hey guys, in this video I'm just going to be doing some reviewing of initial Etherchannel configuration when we are working with Etherchannel. So this is a lab from Boast.NetSim, which is a brilliant platform for practicing CCNA lab skills. If we look in, I'm doing task 2 now. This lab's about LACP, which is the open standard protocol for port channeling or Etherchannel, as Cisco refers to it. But so what we're going to do is task 2, question 1, display the links that are available to form an Etherchannel. So how do we do that? To discover the links that are available, what we need to use is a command called show CDP neighbors. So if you notice, I'm already in privileged exec mode, so I can begin typing show to CDP neighbors. This shows me, okay, I can see 10 interfaces here on a switch called DSW1. So DSW1 is here. It is connected to ASW1. You can see these channels here in between them. So it can see 10 interfaces there on that switch. So if I do likewise on DSW1, show CDP neighbors, you can see 10 interfaces on ASW1. We can see 2 interfaces on CSW1. So we can, these are 10 fast Ethernet interfaces. These are 2 gigabit Ethernet interfaces. So that's for the first one. Is output from the show CDP neighbors command shows that ports fast Ethernet 0-1 to 10 form links to fast Ethernet 0-1 to 10 ports on DSW1. These 20 output ports form 10 links that can configured to form a channel group between ASW1 and DSW1. So next, observe the line and protocol state of each interface on ASW1 and DSW1. So for that, sorry, I wasn't supposed to open that actually. Line and protocol state can be done by using command show IP interfaces brief. Oh, sorry, I show IP interface brief. Show IP interface brief on ASW1 shows us current status of the ports on the switch, so we can see fast Ethernet 0-1. Sorry, grab any comments in the way. 0-1 to 12 there. 0-1 to 12. You can see the default VLAN there. VLAN 1, which is to begin with, when you have a switch, all the ports are on VLAN 1. It's something can't be modified, can't be deleted. VLAN 1, it's there out of the box, configured in a switch. So we got 12 interfaces, fast Ethernet interfaces. DSW1, do the same. So show IP interfaces brief. Little issue. Show IP interfaces. Oh, sorry, IP interface, not interfaces. So we can see 12 fast Ethernet interfaces there, and we can see 12 fast Ethernet interfaces, and we can see 2 gigabit Ethernet interfaces, VLAN 1, and obviously we can see the lines and protocol status. So we can see majority are up. 11-12, fast Ethernet 11-12 are both down, and for ASW1, everything's up bar fast Ethernet 0-12. So like it says here, use the show IP interface brief command to verify the line and protocol status of the interfaces. Number 3, verify that an active trunk link exists between W1 and DSW1. Which trunk encapsulation type of both which is using? So for this we use a command called show interfaces trunk, and this shows us that there are 10 interfaces, fast Ethernet interfaces, which are all trunking, so all got trunks configured, and they're all in desirable mode, so they all want to form trunks. All these interfaces want to form trunks, which is good, and you've got 821.q encapsulation, and these are all in the native VLAN 1. So that's great. Next off, DSW1, do the same again. Show interfaces trunk shows us we've got 10 interfaces all in desirable mode, 2 gigabit ports which are showing us on mode. So yeah, these two look like they're trunking with each other. They've got 821.q encapsulation trunking there. So it looks like we've got an active trunk link. Yeah, so you can issue the show interfaces trunk command to observe the trunk state and encapsulation type of each port, all the ports, but should display that they have negotiated 821.q encapsulation. Sample output from SW1 is shown below. And then lastly, when the lab is loaded, all 20 interfaces have identical configurations. Why is this important to know? So go to the lab, and why is it important that all 20 interfaces have identical configurations? Well, so this is nothing we need to lab here. This is just knowing. This is just something that we need to know about Etherchannel and port channeling. Etherchannel strict port channeling is that there needs to be identical configuration, i.e. LACP on either side of the on either interface, on each switch. So or PAGP on both sides. You can't have a mix and match. They got to be the same. So you either have LACP on both sides or PAGP on both sides, or you have on both sides. If you're not going to use either of them. But you need LACP or PAGP on both sides. So that's why it's important to have identical configurations on the interfaces on each end. So it's important to know that all 20 interfaces have identical configurations when the lab is loaded, because ports that form a channel group must have identical configurations. So that's it, guys, for this video. This is task 2 of this lab, which was Etherchannel negotiation protocols LACP, part of Boson's and NetSim, CCNA, NetSim labs. The next video will be about task 3, which is all about configuring Etherchannel using LACP, and this will be more in depth. So stay tuned. Thank you for watching.